Welcome to Ask Caleffi, the podcast that dives into real-life problems that plumbing and HVAC technicians face in the field. We're your hosts from the Caleffi Tech Support Team. I'm Greg Tubbs.
And I'm Dan Furcus. Welcome. We look forward to sharing some stories from our tech calls and using our background and expertise to make your days a little easier.
Hey there, welcome back to the Ask Caleffi podcast. Here in Milwaukee in the studio today. How we doing, Dan?
Oh, I'm doing great today, Greg. How about you?
Oh, can't complain. It's fall. Phones are ringing.
Leaves are falling. Phones are ringing.
Yes. Lots of Halloween candy being passed around.
Oh, yeah.
Even long after.
Right.
So, what are you seeing coming in on the phones lately?
Oh, man. Phones have been busy. Lot of calls. You know, one call we get a lot of is about domestic water recirc and mixing valves.
We sure do, and it seems like it's after the fact. Once either, I think mostly it's mixing valve related. It's 9 times out of 10 it's going to be because our product has been installed.
Right, with the recirc line.
Right,
something's not acting or performing right.
Right.
Yeah, and I mean we don't sell pumps. We're not a pump manufacturer, so you know, as far as like recirc lines and recirc pumps, we don't get involved with that. But but our mixing valves, you know, when you start putting in a mixing valve into a project, a recirc line becomes a really critical part of the performance of that mixing valve.
Yeah, it certainly does. You know, the pump has to be properly sized, and let's hope, and we can hope, but it doesn't always happen, that the piping is also properly sized for the velocity that's going to be moving through it.
Right. Yeah, there's a lot to consider there. You know, you start looking at flow rates and pipe sizing and pipe material.
Yes.
You know, especially pipe material. When you start looking at velocities in domestic water recirc systems, there's limitations that you can't exceed.
Right. Not all piping is created equal.
No. I mean, for example, you look at copper.
Yes.
You don't want to exceed 5 feet per second in copper.
No, because then you have to worry about corrosion.
Right.
But then you'll get like-sized PEX.
Yeah, and guys think, PEX, hey, I'm going to run PEX because PEX is going to be really easy. I'm going to put it in, staple it up, run it back. But boy, 2 feet per second in PEX.
Yeah, that's pretty rough. That's a very, very major decrease in velocity.
Yeah, I mean, it definitely changes the pipe size requirement. You know, if you're looking at a 3/4 inch copper line or a 3/4 inch PEX, your flow capabilities are going to be quite a bit different.
Certainly are. And then you have some jobs where it's CPVC where they can flow more, but it's not always the nicest to work with.
Right. Well, what happens when you exceed that velocity?
You exceed that velocity, no matter what the product is, you have to consider that potentially you're going to have a problem with corrosion.
Absolutely.
It's going to eat away at that piping. With copper, it turns into a miniature sprinkler system, you know, over time. Like it might start pinholing in certain areas, maybe where the velocity picks up around an elbow.
Right.
You see that a lot.
Well, and that's really why pipe sizing and system design is so important. And, you know, because so many guys think, oh boy, I'll just change the pump. You know, I don't have enough recirc. I'm not getting the performance I want. I'll just put a bigger pump in.
Yeah, more cowbell.
Yeah, exactly. But that's going to change your velocity, and you're right. You're going to start to have pinholing, or the pipe's going to degrade.
It certainly will. It's not going to last long.
Yeah, especially PEX. You know, PEX has that low velocity.
Very low velocity. So, in a perfect world, ideally, to really wrap your head around it, a perfect recirc system would, I don't know, I think of what I would want to see in a perfect recirc system. Properly sized piping, properly sized and calculated pump.
Yep. System balancing. That's very important.
The right size mixing valve. Because most of these systems have a master mixer in them.
Right. Yeah, you'll see that, especially commercial properties, commercial buildings. You know, you're going to see a master mixing valve. You'll see a domestic recirc system. You know, and face it, when you start getting into a hotel or a hospital or something of that size, you know, you put in one master mixing valve, ASSC 1017 mixing valve.
Yep.
to be able to achieve and provide the maximum flow rates you need at an acceptable pressure drop, that valve's going to have a pretty high minimum flow rate.
It will. Yeah. In order to keep the velocities down, you have to have a big enough valve to be able to handle it.
Right. Right. Exactly.
What about balancing? I mean, we make a lot of different balancing products, but there are cases where some balancing valves are better than others.
Yeah, there are.
Or even just having a balancing valve is better than not having one at all.
Right. Well, and if you have your system designed and calculate it right, I mean, you can put in, we have, like our flow cals, our 127s, where
very popular.
You can pick a set flow rate for that mixing valve, and it's, pressure dependent. I mean, it's going to provide that exact flow rate within a pressure differential range.
Right. A lot of systems like what we're talking about, in cases they have to be, that flow rate's got to be confirmed. So then you got to add PT ports.
Right.
Another great option would be like the 132.
Yeah. The 132 is easily adjustable.
Yeah, it's a pull pin, and you can make the adjustment, and you don't have to really, that's your verification.
Right.
Balancing guy can pull that pin and see where it's at.
Yeah, anybody, a balancing guy, an inspector, a maintenance guy can come around, pull the pin, check your flow rate, has a flow rate indicator that you can position when you set the system up so that anybody trying to verify flow knows what it should be set for.
Right. And then I think one of my new favorites has got to be that 116, that thermal setter. The fact that it essentially self-modulates as the risers heat up and cool down. It opens and closes as needed, it allows that water to continue flowing because water's lazy and push onto those further risers that aren't maybe getting as good a flow.
Yeah, you're right. I mean, when you start balancing based on temperature, water is lazy. You said it. Water takes the path of least resistance. So, you might have shorter risers that are going to come up to temperature relatively quick, and they're always going to have flow through them. And then risers that are further away that are going to have more restriction, more resistance, and they're not going to come up to temperature as quick or balance out. So the thermostatic balancing valve, the 116 thermal setter, as soon as that riser comes up to temperature, it's going to start to modulate the flow down, never close off all the way, but modulate the flow down and then push that on to the next riser.
Right. So properly balancing a system, whatever product you want to use, as long as it's being properly balanced, that's going to save a lot of energy.
Yeah. Well, and I mean, boy, you talk about the thermal setter being one of your favorites.
Yeah.
I couldn't agree more. You start looking at today, with all the variable drive pumps, what better, okay, so you put in a variable speed pump and it can modulate its speed based on pressure differential.
Right.
And then you pair that with a temperature or thermostatic balancing valve that can modulate its flow rate based on the temperature of the loop. How much more efficient could you get?
I don't know how you could get much more efficient, but we see things more often than not, that are kind of the fly in the ointment. Missized piping, incorrectly set up pump, or wrong size pump. Piping is probably the biggest thing, though.
Yeah, absolutely is.
Not only size, but just how the system is piped. I mean, that's a rabbit hole we can jump down, and I think it's worth jumping down. But I just took a call today where it was a assisted living complex, and they had problems with another set of thermostatics that they had put in.
Okay.
The contractor said, "Oh, we'll put this Legio mix in, and it'll make all your problems better." Well, they put it in. They had a little more control.
Okay.
Over the old thermostatic, like they couldn't get below 130, and this facility gets inspected regularly.
Okay.
Not to exceed 110 degrees out of the faucets, and they don't have anti-scald in place.
Okay, but they weren't able to control it below 130.
So originally with the old ones, not below 130.
Sure. Now
with the new mix valve, they got it down to 120, but it was fluctuating a bunch.
Okay.
So talk to the guy on site. It happened to be the maintenance guy who who we most of the time end up talking to, because the plumber installs it and his job is done. He moves on.
Right.
Well, the guy that's on site, the maintenance guy, is constantly monitoring this. He's in charge of this. This is his baby. So he is monitoring it, and, he calls and says, hey, this thing's just not doing what it's supposed to do. So one thing leads to another, going through some things, find out what size valve it is. So, okay, we know it's 1.5 inches.
Okay.
All right, 1.5 inch valve has a minimum flow requirement of 6.6 gallons per minute.
Yep.
All right, do you know what size your recirc is? Well, it's piped in 3/4. Okay. Do you know what your pump curve is telling you? What can that pump handle,
Right.
on speed X? Because it wasn't a variable speed pump. It was a fixed speed pump.
Sure.
And it turned out it wasn't speed adjustable. It was one speed, and that was it. He didn't know. And you can go digging, and there might be 4 variations of that pump, and it's hard to know which one it is.
Right.
We know it's one with either stainless or bronze volute or a brass volute,
Right.
but we don't know which variation it could be.
Sure.
So that's the tough part, is knowing if your pump is too big or not big enough.
Right.
In some cases.
Yeah, absolutely. You need to know that you can provide
Sure.
the flow rate to meet the minimum. And you know what? One great test, if you are on site and you have a mixing valve that's hunting around and it's not meeting minimum, is to shut the recirc line off, shut the pump off, valve it off, and then go out into the building and open enough fixtures so that and confirm that you're flowing more than your minimum flow rate. And if that valve steadies and controls, it's not a valve problem, it's a recirc problem.
Right. So here's the icing on the cake with that. This pump was wired in with all the boilers on a master kill switch, along with several other pumps throughout. Why they did that way, I don't know.
Okay.
So he could not shut the pump off without shutting the boilers off and sending some sort of an alarm, which was kind of frustrating.
Okay.
So I said, all right, let's discuss what the piping looks like. I said, you should have from the recirc return past the pump, downstream of the pump, it should go to 2 places. One, it should go back to either the cold supply of the tank or a dedicated recirc port in the tank.
Right.
And 2, into the cold inlet of the mixing valve, sharing the cold feed.
Okay. Right.
Check valves need to be in place. Isolation valves, highly recommended.
Yeah, and good thing about that is in every one of our installation manuals, we provide that pipe drawing.
We do. For those who are good at looking at installation instructions, it's there.
Yeah, we make it easy. It's in every one of our mixing valves has that drawing in the installation manual.
Certainly does. And we have other variations that if you call here, dual tank, dual valve, we have some drawings that we can share.
Sure.
So, the fly in the ointment here. The only place the recirc return was going back to was the tank.
Yep.
He had the valve set on set 1 temperature, down as low as he would want to go with it at 104 degrees.
Sure.
He was still getting 126 degrees out at the faucets over time.
Okay.
The system was creeping.
Yeah.
The system was creeping, so that's why. And it has no way of dumping hot water once it's creeped up unless someone opens a faucet for a period of time to dump that hot water out.
Right.
It has no way of cooling off.
Oh, exactly. And, when you're not... That's why the problem got better with the Legio mix than it did with the thermostatic.
Because it closes off, but it takes time to close off.
Right. Yeah, the Legio mix will close off hot or cold 100%, where thermostatic typically won't.
Right.
But you're right. He had that mixing valve coming back on the cold side of the valve, once his recirc line was up to temperature, it would recirc through the mixing valve.
Right.
Through the cold port, back out through the mixing valve, add a little hot as it needs to maintain the desired mix temp, and the valve would perform well for him.
Yeah, so now he's calling his plumber back, and he's going to have him tie that bridge in.
Sure.
Right to the cold inlet of the mix valve. So that way you're not deadheading your pump. Mm-hmm. If you were just tied into the cold side of the mix valve, it wouldn't deadhead. If you had check valves in place like you're supposed to,
right,
keep water from flowing backwards where it shouldn't go.
Yeah. I had an interesting one as well.
Did you?
So again, it was with a Legio mix, and the problem the contractor was having is that he had his mixing valve set to deliver 115-degree supply water out to the building, but he was getting 140-degree water out to the building.
Whoa.
So we started diving into it, and it's like, okay, hold on. You have the mixing valve, and it's set to deliver 115 degrees out to the building, but your building loop is 140 degrees. How is that happening? And what we determined is this was a commercial building where they had a high temperature line and a mixed temperature line. So the mixed temperature line fed the rooms in the hotel. The high temperature line fed the kitchen, but they had a recirc on both. And when we looked at where the recircs were tied in, he had it tied in to the cold side of the mixing valve.
They were sharing a return, weren't they?
Yeah, he had.
Oh no!
He had a high temp recirc and 3 mixed temp recircs all tied into a manifold, and then it split. And one side went to the cold side of the mixing valve, and the other side went back to the tank. So he had it piped right.
Sure.
Except what happened is you're bringing that high temp recirc back.
And keep in mind that high temp should have its own pump, and the mixed low temp, we'll call it, the mixed temp recirc should have its own dedicated
recirc. Well, and they each had their own pump. But the problem is they were all tied into like a manifold and then came back to the cold side of the mixing valve in the tank. So what was happening is the mixing valve said, okay, we don't have any use in the building. I need 115 degree water. And it's seeing 140 degree water from that high temp recirc coming in on the hot side. And it's saying, okay, I need more cold. So it's it's shutting the hot off coming into the mixing valve. But the cold side, which is the recirc water coming back, is 140 degrees because that high temp recirc's coming back on the cold side.
Certainly is. And it's dumping in.
Yeah. So with that, they had to actually split that high temp recirc and pipe that back to the tank on its own and separate that from the mixed return, so that now the mixed return is able to run through the mixing valve, and the high temp return is always going back to the tank.
Well, and it's tough to try and keep everything straight for these guys in the field too, because every job is different, and a lot of our product, Legio Mix especially, is going in as a replacement for old thermostatics that are very expensive to replace or rebuild.
Right.
So you're kind of, as the plumbing contractor in the field, your back's up against the wall to do it as inexpensively as possible and to do it quickly.
Right.
Get the building back up and running.
Oh, sure. And sometimes you're out on an existing building, an existing recirc. You
don't know where it's coming from.
Right.
You don't know if it's even hitting half the building.
Exactly. Does it have balancing valves?
Don't know.
You don't know. You need to find out.
Yeah.
Yeah.
I talked to a guy with a 70-year-old building this morning, and he's like, I'm pretty sure there's no balancing to be had in here. Right. There definitely isn't anti-scald, but they want to do Legionella control, and that's another subject for another day. We'll jump down that rabbit hole another time, but
whole new set of requirements.
Whole new set of requirements that we'll talk about maybe another time, and I'm sure we've covered some of it on previous podcasts, but. Yeah, there's certain components that got to be installed in order for that to work properly without someone getting sued or killed or hurt.
Yeah, that's a challenging retrofit because there's so many additional pieces that need to be added. Recirc line is super important with thermal disinfection. I mean, that's how you're achieving thermal disinfection and proving it's complete.
Right.
Again, that's a whole podcast on its own. But you start getting into existing buildings where recirc was marginal to begin with, you really need to look and see what you can do to make sure that that's going to be adequate with your new mixing valve or new pumps. Thermostatic balancing valves work great in that application. They
certainly do. Well, I think we had some pretty good information on recirc. Hopefully it's helpful to you guys. We hear about it several times a week, and I think it's always a good topic to cover. So I don't know if you want to hear something more about recirc or any other topic, hit us up on our tech email.
Yeah, anything you guys can think of that you want to hear us talk more about or you want to learn more about, please send us an email.
Yeah. Thank you for tuning in. If you ever need help,
please feel free to contact our tech support team anytime at techsupport.us@caleffi.com.
Or call us during our business hours at 7:30 a.m. to 4:30 p.m. Central Time at 414-238-2360.